Hi, welcome to QuickInfra. In this video, we will walk you through the various features of QuickInfra. QuickInfra comprises of 4 modules: infrastructure creation, setting up of DevOps infrastructure and CI/CD pipelines, deployment of applications and databases, and creating a customized landing zone to enable advanced security, governance, and compliance across multiple AWS accounts. Let us start with a quick demo in which we will be creating a 3-tier infrastructure on AWS and deploy a demo application along with a MySQL database. And finally, we will see how to set up a CI/CD pipeline to deploy a sample application onto the target infrastructure. Let's log in to QuickInfra. Once we log into QuickInfra, we see our dashboard that displays the various pipelines that we have created, the infrastructures that we have created, the various types of deployments, landing zones, and the cloud accounts that we are managing. First, we will set up the cloud accounts. This is the only sensitive data that we store in QuickInfra, such as the access key and the secret key, such as sensitive values are encrypted at various levels. First, in the browser, if you do a view source, we will see such and sensitive values encrypted. These values change on every page refresh. Secondly, the data traveling over the wire is encrypted using HTTPS and SSL certificates. The disk volumes attached to the QuickInfra servers are encrypted at infrastructure level. And finally, the data stored in the QuickInfra database is further encrypted using our custom algorithm before storing it into the database. Once we've configured the cloud accounts, we will now create the infrastructure. To create the infrastructure, we have a library of various customizable infrastructure templates. We can pick and choose according to our requirements. These templates are an answer to a business use case. For example, you might want to create a 3-tier infrastructure on cloud. Basically, it will consist of 3 layers: the web layer, the application layer, and the database layer. Here we are creating the web servers, the application servers, the database servers. Along with this, we are also creating a monitoring server that will automatically discover all the servers and show them on a dashboard. Then we have a template to create an infrastructure in multiple zones. This is a single zone. This is a multi-zone infrastructure where we will be having load balancers, auto-scrolling groups, high availability enable. We also have templates for creating the various DevOps pipelines, setting up the DevOps infrastructure, setting up CI/CD pipelines, targeting the various repositories, code commit, GitHub, GitLab. We also have templates for deploying applications and databases on containers, as well as on EC2 instances. We also have templates for data migration, wherein we can migrate the data from data center or on-prem database servers to cloud servers. Now let's dive into the demo. We will create a single AZ 3-tier infrastructure with a monitoring dashboard on which we will be deploying a sample demo Java application. So we'll select this template, create a copy of this template. I will have already created a copy of this. Now on creation of a copy of this, it will now be available in my infrastructure menu. This is the project that we have just created from the infrastructure template. This is a customizable template. Here we can add, edit, remove services. For example, I don't want to create a monitoring server. I can disable it or I can delete it. If I want to add a load balancer, I can add it to this template, and once I have customized this template, I can generate Terraform and execute this script against my target account. So let's modify the web server. So here we can create multiple servers, how many servers we want, what is the type of the operating system, whether it's Linux, whether it's Windows. For Linux, it has the various options to create data, the various types of data. So here operating systems, Red Hat Linux, SUSE Linux, Kali Linux, Ubuntu, or for Amazon Linux, we have a special value. This value will pick up the latest operating system that is available at that point in time. Here we have the option to select the size of the infrastructure, the size of the server. Let's say we want to create an 8 CPU 16 GB RAM server in which network we want to create. and which subnet we want to create. Here, we can attach the script that will be executed in this server during its first run. So here we have, since it is a web server, we have selected Apache HTTP reverse proxy. We are also installing CodeDeploy agent. We are doing Linux updates. We are also installing a node exporter on this. Similarly, for the web server, we have an option to select Linux common updates, MySQL, node exporter. Along with this, we also have an option to pass certain parameters to my database script. For example, I want to create a database with this name, or I want to change the root password with this name. For demo purposes, we are showing this in plain text. Actually, these values will be stored in a security vault like Secrets Manager, and here we will refer only to the keys of these parameters, and during runtime, these values will be picked up from the AWS Secret Manager. If you want to create a spot instance rather than an on-demand or a reserved instance. So here we can specify that the target spot price, and if the price is reached, the server will be created. If you want to create an EBS volume of a size other than what is available in the EMI, so here we can configure this, and once we have done this, we can now generate Terraform. Once we have configured this template, we can now generate Terraform. We'll select the target account in which we'll be creating this. Let's say this is my demo account. The heart of QuickInfra is the Terraform generation engine. We can now generate Terraform, we can execute Terraform, we can create infrastructure, we can remove infrastructure. If you want to check the pricing of running this template of running this kind of infrastructure on AWS, how much it will cost for 1 day or for 30 days. So this will be the pricing. So now we will generate Terraform. Okay, Terraform is generated. We will now execute the Terraform into the target AWS account. It will take a couple of minutes for the execution. The creation has started. It will take some time for the entire infrastructure to be created. So at the end of this activity, we will have a fully compliant 3-tier infrastructure on AWS as per the recommended best practices of the industry. Okay, the infrastructure is now created. So let's check the servers. So these are the management screens from which we can manage the servers. We created this in AWS. This was the demo account. This was the infrastructure template. This was the infrastructure project. And we created this in Mumbai region. Now fetch the servers. So here we see the app server, the Bastion server, monitoring server, database server. The web servers are created. So from this screen, we can start, stop, reboot, delete the servers, create a backup image of the servers. Here we can modify the data volumes, the EBS volumes. For example, let's say I want to change the hard disk size, the volume of my Bastion server to 16. I can make it 16. If I want to encrypt it, I can encrypt it. So these are the various actions that can be performed. If I want to take a backup or a copy of a snapshot of this EBS volume, I can take this. You can detach this volume, attach it to another server, delete this, modify it. I create a new volume and attach to the same instance. So these are the various management screens that can help us to manage the instances, the images, the volumes, the network, the subnets, the custom scripts. If we have some VMware environment or some hypervisor environment and we can import virtual machines, we can export them. Now coming back to the instances, as part of this template, we have created a monitoring server. Let's see if the monitoring server is up and running. So this monitoring server is based on Prometheus and Grafana. We'll log into this. So here we have provided 4 dashboards out of the box, 2 for Linux monitoring, 1 for Windows monitoring, and the 4th one for the log files. We'll now check the Linux servers. So here we see the web servers, the application server, the monitoring server, the database server are created. The standard matrices that are displayed on the dashboard, how much CPU is utilized, how much RAM is consumed, how much hard disk is consumed. Now this application server is showing red because after Linux updates, we are installing Java on it, and after Java, we'll be installing Tomcat server on it, so it will take a couple of minutes for the entire server to get ready. Okay, so it has now stabilized. Now let's check if my web server is up and running. If you see the default page, that confirms that all my 3 tiers of the infrastructure are working fine. Yes, so now we can see the default Tomcat page. My web server is redirecting the request to my application server, and my application server is now connected to my database. Now the next step would be to deploy applications and databases onto this target infrastructure. So right now, what we have is fully compliant, well-architected, 3-tier infrastructure with all the best practices, with the latest patches, with the latest middleware install. It is a fully modernized infrastructure. Now let us get into the deployments. For deployments, we have various deployment templates. We have templates to do Linux updates across multiple servers. If you want to do some configuration management, copy multiple files, deploy custom applications, deploy databases, import data, export data on Linux instances. Or on Windows instances, let's say you want to install Google Chrome on hundreds of Windows servers, you can select one of these templates. So for demo purpose, let's deploy a 3-tier Java application and MySQL database, demo database onto the target infrastructure. First of all, we will deploy the database server. For that, we will select a MySQL template. And before that, we need to copy the database and the demo application somewhere on cloud when it is accessible. So I have already copied it into one application, S3 bucket, and that will be my source location. We will select this template. So I have copied this in an S3 bucket. It can be S3 bucket, some FTP server, some GitHub URL, anywhere on cloud when it is accessible. This is the location, the URL of my database export, database dump. This is the temporary location in which it will be downloaded. This would be the database. If the database is not created, it will automatically create it. This will be my root username and password. For demo purpose, we are showing this in plain text. Actually, this will be the keys to the secret manager in which we will be storing the actual values. Now we select the target infrastructure project. So this was a 3-tier infrastructure project in which we have created the infrastructure. This will be my target account. We will connect to it, fetch the servers. We select all the database servers. For demo purpose, we have created only one database server. Now this database server, it is in a private subnet, not directly accessible over the internet. So we will connect to it through a Bastion server. Only this Bastion server has access to my database server. So we will log into the Bastion server, create a tunnel into this database server, and import the data. Save the project. Project is saved. Generate Ansible script. Script is generated, and now we will execute the script. Now this script will create a temporary credential to download the data from the database dump from my S3 bucket. It will copy it into a temporary location. If the database is not created, it will create the database, and then it will import the script into the newly created database. Okay, my database is now created and data is imported. The next step would be to deploy a Java application. So we will see like this Java application template here. Again, the procedure is same. Here we select the types of application. So whether it's a Java, Net, Python, if it's a data import, or whether data export, or whether it's MySQL, Postgres, Oracle, you can select the type of the application. So here we have selected the custom application. It can be Java, Net, Python, Angular, the target operating system. The source location, it is my S3 bucket. This is my demo application URL. This will be the location in which it will be downloaded, and after downloading, it will restart Tomcat. So here we will select the target infrastructure project in which we want to deploy Java application. This is my demo account. I will connect to it, fetch the application servers. So for demo purpose, we have created only one application server. Again, this is in a private subnet, not directly accessing over the internet. So we will log into the jump server and then turn that into the application server and deploy the application. Save the projects, generate script, execute the script. Again, this script will connect to my history bucket, create temporary credentials, download my Java application, reach into a temporary location, deploy it in Tomcat, and restrand the Tomcat service. My application is not deployed, so let us check if the application is up and running. So the name of the application was Demo. Yes, so my application is running. This is a simple credit application, so I can create a new product. Okay, so here my data is there. Let's say I want to re-import my data again. I've deleted all my data, and I want to re-import the data again. So it's very simple. We can again go back to our database import template. So this was a database project. So we select it. It is already pre-configured. We've already set up the servers. We just need to execute the script. This script will again download my data from the S3 bucket, re-import it back into my database. The same approach can be used to deploy a new version of the application. So instead of demo, I want to deploy, let's say, demo 1.1. I can just change the URL to demo 1.1. Select the servers. Execute the script and the demo 1.1 application will be deployed on all to the target infrastructures. So here we have the successfully executed. Again, we'll come back to the application refresh and my data is back again. So this was a manual way of deploying applications and databases across hundreds of servers, multiple accounts, multiple target environments. The next approach would be typical DevOps approach to deploy applications and databases onto the target infrastructure. Now let's see how we can deploy the application through DevOps approach. For that, we have various templates for DevOps. So there are two parts to DevOps. First is we create an infrastructure on which we will be deploying the applications, and second would be to set up the CI/CD pipeline that will download the code, build the code, test the code, and deploy it onto the target infrastructure. So I've already copied the DevOps infrastructure, the project and the pipeline projects, and now they are available as part of my infrastructure projects. So first we will create the target deployment infrastructure. So here we will create a simple infrastructure consisting of two servers. One would be a blue server, another would be a green server. First, we will be deploying it on the blue server, and then in the next version, we will deploying it into the green server. That is how we can switch between the servers version 1x and 1y. Finally, once we have done this infrastructure, then we can create a CI/CD pipeline to deploy the applications or to the target infrastructure. We will select the target account, generated, the reform. The reform is generated. We will now create the target dev of infrastructure. It will take a couple of minutes for the servers to be created. Okay, the infrastructure is now created. We will now check the servers. It was an DevOps infrastructure template that we created. So here we see the blue and green servers are running. Now we will create pipelines. We will select this CI/CD pipeline. Select the target account. Generate Terraform. And okay, the other pipeline is created. Let's check the pipeline created this on AWS. This was the account. Okay, here we see the pipeline that is created. We will see the executions. So it is in progress. It will take time to execute. It will pick up the code from the repository. It will build the code and deploy the code onto the target infrastructure. Check the details of the CI/CD project. As part of this project, we are connecting to a code repository. This can be code commit, GitHub, Bitbucket, GitLab. If you want to create a new repository, we can set it to yes. This will be the repository. This should be the branch. And this will be the user who will be approving the creating developers who have access to upload and download code to this repository. Then we have a build project here. As part of the build project, depending on the number of builds, we can decide the size of the server, whether you want a small server, the medium server, large server, how many applications or microservices we are building. Let's say you want to build tens of microservices or 10 projects. If you want to upload the build into some Docker hub or some ECR repository, we can create a user or role with these privileges. If you want to pass certain values as environment variables to the build script, you can pass it here. We have the actual deployment project here. As part of the deployment projects, we have multiple types of deployment. Whether you want to deploy it on virtual machines, EC2 instances on containers, or serverless deployments. For EC2 instances, it can be deployed in place or a blue-green. If you are deploying it on containers, we have an option, whether you want to deploy it on the same containers or a blue-green container. In place, we will deploy the new application onto the same set of containers or servers. There will be a small downtime wherein the application would be replaced with a new one. If we don't want any downtime, so we can go for a blue-green kind of deployment wherein a new set of servers or a new set of containers would be created. And the new application will be deployed on the new container. And once the deployment is completed, then we can transition the traffic. Based on the parameters that we configure, let's say I want to transfer my traffic 10% of the traffic every 1 minute to the new environment. And once everything is fine, the 100% traffic is shifted, whether you want to delete the servers or keep them as it is. So whether you want to roll back to the old version or you want to delete. So once we have configured this, then we can actually set up the pipeline. So here we have the various stages of the pipeline. So this is the source stage. This is my repository. This is the branch name, whether you want to pull for any changes. So whenever anybody pushes a new code, it will automatically be downloaded built in. Okay. If you don't want to build it automatically, you want a manual trigger of the pipeline, then we can go to the pipeline screen and then execute it manually. Then which is my builds project? Oh, do we need an approval before that it is deployed to the target infrastructure? Mostly this is required for production purposes. Unless somebody approves it, I will not be deployed. And then finally the deployment projects. Oh, we can add multiple stages here. Let's say I want to do a static code analysis. I can add a new stage here for testing, and here I can configure my SonarQube details here. Oh, if I want to do some dynamic code analysis using some Selenium script, I can add another stage here. I can invoke my test cases here. Okay, I can remove add stage. I can remove stage depending on my requirement. Once I have configured my template, I can set the target account, and I can now generate the Terraform script, and I will now create the project. Okay, that's how it is done. Let us check the pipeline. It is still in progress. It will take some time for the application to be deployed. The source will be downloaded, built, and deployed onto the target infrastructure. Okay, the pipeline has now succeeded. Let us check the various stages of the pipeline. So the source is succeeded, build is succeeded, and deployment is succeeded. We will now verify whether the application is deployed. So this is the URL. Let's go on in. Okay, so the application is now deployed. Once we are done with the testing of the application, we can again come back to the project. We can just terminate the infrastructure, delete the pipeline, take a backup, and restore it again. So we can manage all this through QuickInfra. Another important part of QuickInfo is we have a user management screens wherein we can assign which user has access to which projects. For example, for a developer user, I can assign in which accounts he can create projects in which account he has access to, which infrastructure projects he has access to, which deployment projects he can work on. And based on that, once we have created the user, he can see only the projects that we have assigned. So that's it in a nutshell about QuickInfra. So we have seen how to create infrastructure, how to create CI/CD pipelines, how to deploy applications and databases, and push the code into the various target infrastructures. If you want to manually trigger the pipeline, we can trigger the pipeline from here. Okay, so pipeline started. If you want to stop the pipeline. So the pipeline is stopped. If you want to see the history of the executions, we can check it from here. The first one was succeeded, second one was stopped. If you want to see the history of all the actions of the pipeline, we can check it from here. So the first source was built successfully. Build was successful, deploy was successful, here the source was successful, build was successful, but we stopped it midway before the deployment phase. Thank you very much.